Hi, you guys. We're going to have a quick review on functions. It's been a little while since we've talked about what a function is, but with a function, every input has exactly one output. So when you're thinking about if something is a function or not, think about a vending machine. If you push one button, you're going to get one thing back. When we look at functions, if it's a function, it will pass the vertical line test. So that means that a vertical line will only touch the graph one time. So if you can pass a vertical line through whatever has been being graphed and it will only touch one point at a time, then you know it's a function, okay? So the first one right here, this is a function. It passes the vertical line test. But this one is not a function because if I pass a vertical line through here, you can see it's touching through more than one point, okay? So if it's not a function, a vertical line will touch the graph more than once. When we're looking at a table of values, if we're trying to decide if something's a function or not, we look at all of the x values, and if it's a function, none of those x values will be the same. The x does not repeat. So the only thing you need to look at if you're trying to decide if the relation is a function is the x value. So we can look here, we've got -2, -1, 0, 1, 2. None of those x values are the same. And we don't actually care about what the y values are if the x values are not the same. So this, we would say, is a function, okay? So this is a function because it passes the vertical line test. This is a function because none of the x's repeat. When we look at this table right here, notice that it is under the column for not functions. So this one was a no because it did not pass the vertical line test. This one is also a no because as we look through our table here, as we look at our x values, can you see that there's more than 1, 2? There's also more than 1, 1. And there's also more than 1, 3. So we have a lot of x's that are repeating. And so if the x does repeat, then you would say no, this is not a function, okay? When you're looking at a set of ordered pairs, when we look at the x values here, we can see that 4 is being paired with a 1, and it's also being paired with a 12. So that input has more than one output. So again, this would not be a function. Okay, so functions pass the vertical line test. With a function, the x does not repeat, and that is in a table or a set of ordered pairs. If it's not a function, it won't pass the vertical line test. The x will repeat, and the input will have more than one output. Okay, so functions and not functions. I hope that helps remind you about those. Now, functions, if something is a function, it can be a linear function or a nonlinear function. So it can be something that's the graph of a line. That's what it means to be a linear function. Or it could be something like this. And this is a function, but it is a non-linear function because it's the graph of something different than a line. So when you're looking for linear functions, you want to look for equations that are already in slope-intercept form. If they're in slope-intercept form, then you know for sure that they'll graph a line. So like this one is linear. This one is not because there's a squared on the x. And anytime you have any exponents other than 1, that will not graph a line. So that one won't graph a line. This one won't graph a line. This one, we have an exponent that it's a variable, so that won't graph a line, but this one would graph a line right here. This one would cross the y-axis at -17/2, and then the slope is 1/2, okay? And we already said this one is a linear function. It would cross the y-axis at -2, and then the rate of change or the slope is -5.5. So we can tell the functions are linear because they can be written in slope-intercept form. Okay. Now, let's go ahead and analyze some functions and graphs. So for A, what we want to do is we want to look at between 0, x equals 0, and x equals 3. So you guys know this is the x-axis right here, and in between x equals 0 and x equals 3, that would be all of this space right here. Okay, so we can see in between that space that the function is increasing, and it's also nonlinear. It kind of makes like a curved, it is going up, but it's making a curve instead of making a straight line. And then if we look at the area in between the 3 and 6, that's going to be this area right here, in between the 3 and 6. Oh, I didn't mean to color that in. So hold on just a second. Let me erase all of that. I really just want to highlight. So I really just want to highlight this area in between the 3 and 6. So I'll just like circle it here. Okay, so we can see that in between that area, our function is decreasing, and then also it's nonlinear. Okay, on the next one, between x is negative 3 and x is 0, that's right here. Okay, so that's all of this space right here, and we can see that the function is decreasing, and it's also linear. And then if we look at the space that is in between the 0 and the 3, that would be this space right here, okay? And you can see that in that space right there, that the function is increasing and linear. Okay, so let's go ahead and quickly look at some of these distance versus time graph. For A, you can see this is our distance on our y-axis, time on our x-axis, and so what's being graphed here is an object moving away at a constant speed. Okay, on graph B, you can see this is our y-axis, and this is our x-axis, so distance over time. And this object is starting a certain distance away, and then as time passes, it starts to move closer. Okay. On the next one, you can see that on our distance and time graph, like time is moving forward, but distance is not increasing or decreasing at all. It's just staying constant. So that really just means that time is moving and the object is just staying at rest. It's not changing its distance. And then the next one, we can see that if we're starting here, the object's like moving away over time, and it's moving kind of quick right here, but then as time passes, it starts to move a little slower. The speed starts to decrease a bit. And then the last one, an object moving away and increasing speed. So we can see that as we move here, it's going further away from where it started, and then right here, that object would be increasing in speed. Okay, so let's go ahead and try some of these situations. It says Tyson is driving, and the graph below represents Tyson's distance from his house. Write a brief description of Tyson's drive. So here's time, here's distance. He's driving from his house. So here's his house. So as time increases, he's driving at a constant speed. And then right here, time is still passing, but distance is not increasing or decreasing. So he must have made a stop right here, okay? And then he returned home at a constant speed. Okay, so let's look at the next one. Maddie is walking to a volleyball practice, and the graph represents Maddie's distance from the gym. So she's walking to volleyball practice, and this is her distance, her starting distance, and then this would be the distance to this is where the gym is at, okay? So she is walking towards the gym at a constant speed, and then she made a stop right here. You can see distance is increasing, or time is increasing, but distance is not increasing or decreasing. And then she walked really fast right here. So maybe she was running because she was late or something, and then she slows down as she gets to the gym. Number 3, the graph below represents the distances of 3 students from their houses. Write the letter of each description over the graph it matches. So Kaylee got on the bus at her house. The bus made 2 more stops before it arrived at the school. So that one matches with A. So she got on the bus. It is going at a constant speed, but then it stops. And then it's going at constant speed, and then it makes its second stop, and then it goes at a constant speed again. For this one, Brennan and his dad left for school. They got stopped at the train tracks before they were able to continue to school. So they're driving to school at a constant speed. The time is increasing, but the distance is not. That's where they got stopped by the train. And then again, they continue their constant speed to the school. And then C, Cameron left for school, but had to go back home to get his English homework. He then drove to school with only 1 stop at a stop site. So he's heading to school, so this is his distance towards or from home is getting further, but then he has to go back home. So time's increasing, the distance back to home is decreasing, and then he goes again, but then he has to stop for a minute, so that's stopping at 1 stoplight, and then he's able to travel further. Okay, and then for the last 2, sketch a distance versus time graph showing Adam's distance from his house. So Adam left his friend Brody's house and started walking home. So this is the distance. This is Brody's house. This is home. Okay, this is going to be home. So he started walking home. He then realized he left his phone at Brody's house. So we went back to Brody's. And then he left a second time to walk home. That would be right here. But then he stopped halfway to talk to a friend he passed. So right here, time's increasing, but his distance toward home is not changing. And then after he talked to his friend, he quickly ran home to make it home in time for dinner. And so you can see that this part of the graph right here, it's a little bit steeper, right? So that's where he is running home. Here he's traveling at a constant speed, not going as fast as he is right here. Okay, and then number 5, Ruby and Gia raced each other in a 150-meter sprint. The graph shows the distance of each runner over time, who won the race, and how do you know? So this is Ruby. Okay, Ruby is going at a constant speed. We can see that Gia, though, and we'll go ahead and trace hers in orange. So Gia, she starts off a little slower, but then as time increases, you can see that her distance increases. Right here, she's moving at a faster rate, okay? So she increased at the end. And then it said on part B, was the same runner in the lead the entire race? And you would say no. Right here, Ruby was ahead of Gia. And then right here's the place where Gia took off, and then she was ahead of Ruby. Her distance right here is higher than Ruby's distance right here, okay? And then how did Ruby's race differ from Gia's? She maintained a constant speed, and then Gia's increased at the end. Okay, so that's your review about functions. For this week's skill review, there is an Alex assignment. It's called skill review number 3. And then I also need you to do the homework number 5 handout that is in the packet that I gave you. This functions assignment is due for a treat. On the Monday, we get back from spring break. So if you have this done on the Monday we get back from spring break, you'll get a treat. You have to do it anyways, so you might as well do it today and get it done so you can get that treat. Okay,